Welcome back to the program, everyone. We're now heading into part 2 of episode 6, where we have a look at functions. So let's head on in to SQL Server Management Studio. Alright then, let's change our database very quickly and start the lesson. Right, now functions, what are they and why are they used? Now there's a variety of different functions that you can use, different types, and we can see those when we expand our databases, go to our database of choice, we'll minimize the tables, and as we scroll down we get to programmability. Open that up and you see there's a lot of different folders there, and we have one called functions. So here we go. Open that up, expand it, and we'll see a list of 4 different function types. First of all, we have the table valued function. If we expand that, we can see there's already one in there. When we restored the wide world importers database, and then we have scalar function as well. There's one in there from that restore as well. Now, the difference between these two, the table valued function effectively just returns a table of values, pretty much like a select statement. When you run off a select statement, your result set is a set of values in a table with multiple columns. So that's what the function does. It will return a set of data in columns and rows as a table. The scalar valued function, however, simply returns one single value. So if you remember when we were doing subqueries, where you had that little select statement in your where clause, where you're comparing a value greater than, equal to, less than, etc., we simply wrote a small select statement to return one single value to use. So that's what the scalar valued function does, is it simply returns one single value, whether that's a string of characters or it could be a number, etc. No matter what that is, it'll only return one single value. Now your aggregate functions, as you can see, there's none stored here, and it's very rare that you will find actual aggregate functions. All aggregate functions are, if we look under our system functions, open up the aggregate functions, you'll see there's things like the average and the sum, all of which we've used in previous batches of code. So that's all an aggregate function is some sort of mathematical formula to group things by a certain item. So you've got all sorts in there, and to be honest, I've never seen an aggregate function, one that's been actually created by a user, because in the system itself, and these are the ones that SQL Server brings in when you install it, it's got pretty much all the aggregate functions that you'll need to use: min, max, sum, average, count, and so on and so on. So you probably will never need to create an aggregate function, or you'll probably never see anyone else creating them as well. Now table valued functions, again, are not very well used all that much. People tend to avoid using those sort of functions because they are quite resource intensive, and I'll explain to you why that's so in a moment as we go through the lesson. Scalar valued functions are more widely used because they're simple, they're effective, you return a single value for what you're after, and that's it, pretty much job done. So why then do we have functions in the first place? How come we don't just simply use a view to return values that we're after? Well, a function is great because you can pass parameters into them. And by parameters, I mean you can send specific values, as you've seen here, into the function itself. The function then performs some sort of operation on those figures that you pass in, and it'll then output a result. So for example, your scalar valued function, what we're going to do here when we create it, we're going to pass in a value for the extended price, and then we're going to pass in a second value, which is the tax percentage. We're then going to, within our function, multiply the two together and divide by 100. And when you see this in action, everything will become clear. So, start off with your create function. Just like creating any other objects, we use the create function, and then of course we type in our schema, dot, and then what we want to call the function itself. Now I've put fn at the beginning. Quite often you'll see UDF for user defined function. Once again, I'm sure your company will have coding standards that they'll want you to follow. Just follow them if you're putting in a little few letters there to designate this as an actual function. And we'll actually call it sales tax, purely and simply, and go forward with that. Now, if I comment out these parameters, you can see that SQL Server doesn't like it, because the whole point in having a function is to be able to pass parameters into it. And by parameters, I mean specific values in order for it to use those values to do its process and then output a specific result. So we're using extended price, which we got from the invoice lines table. So for example, this whole function revolves around taking the extended price and then multiplying it by the tax percentage to get a final price at the end of it all. That's all this function is designed to do. You have to put the type that you're expecting, the data type, against the variable, which you begin with an @, and more on variables as we go through the course later. Suffice to say, we designate extended price as our variable by putting the little @ symbol at the front. Now the reason why I've put decimal 18,2 is if we go down to our tables, all the way down to sales invoice lines, if you right click on that and design, it'll bring up the actual table makeup itself. So as you can see, you've got the column name, it tells you the data type and whether it allows nulls or not. And if we go down to extended price, we can see that it's decimal 18,2. So we're effectively going to be using the source table's data type, and we're going to put it as the data type for our variable there. Now if you want to add more variables, you simply put a comma and then write your next variable there, not forgetting the @ symbol at the front, and put the data type against that as well. And you can continue adding more and more variables with your commas within these two brackets as you see fit to create your function. Now I've used float for tax percentage because we simply don't know how many decimal places a tax value will be. You could have just 15%, or you can have 15.5% or 15.25%. We're not too sure what's going to go in there. At the end of the day, you could put any value, so we went with float on that one. And of course, it will return float. So what you're saying here after your create function is you need to tell it what it needs to return in the case of a scalar function. So we want to return a float value. That's what we're going to return at the end once it goes through the code itself within the function. Next, we need to type the word as. So similar with views, we need to create it, then as, and with scalar functions, we need to use the word begin. So this begins the start of the actual code that's going to be used to generate the final result that's going to be calculated. And of course at the end of the code we need to put the word end there. We put in go just to make sure that there's no red lines coming in here. For example, if we do that, you can see it can't find the function there. So we'll do go, and that tells SQL Server that create this function, and then we can run the select statement and it'll all be fine. So what happens then within the code itself? Once you've begun the process, what you type here is return. So this is what is going to be sent back in your result set. So we're going to return the extended price, whatever gets passed in there, whatever value, decimal value. We're going to multiply it by the tax percentage, whatever tax percentage gets passed in there, and then divide it by 100. If you remember mathematics, to get your percentages, you always divide by 100, and that's our formula there. So that's what we're going to return, that value multiplied by that value divided by 100 to give us our one single scalar value in order to return back. So let's see this in action, and it will all start to make sense. Create the function as you would do, execute the code, and off we go. Create it successfully, and now if we go down back to our functions, we've done a scalar value because we've returned a data type. So all we'll do here, refresh that, hit F5, and there you go. There's our function there. So we know it now exists within the database, so we can use it to our heart's content. So how do we go about actually using the function? Well, we can simply write it within a select statement. So this was one of the views we had in the previous video. I'll comment that out for now. And if we have a quick look, this pretty much returns this data. So you've got invoice quantity and you've got the invoice amount there, based off the extended price. Now what happens if we wanted to show the invoice amount plus the tax itself, or just the tax of this invoice amount? Well, we can use our handy little function here. All you need to do is simply bring it in as an additional column. Make sure you put the schema and the function name, and then of course we need to pass in our two parameters. So the first parameter, we start with a round bracket. First parameter we're going to pass in is our extended price. So we're going to be passing in this value for this row here, 1987.2. And we're going to say we're in the UK, so at the time the tax was 20%. So we don't write it as a percent or anything like that because SQL Server will get confused. We just simply state the value, 20%. Close our bracket, make sure it's separated by a comma, and that's our two parameters that we pass in. One is the actual column itself, and the other is a value that we hard-coded value that we simply put in. We could change it to 15, or if you're lucky enough to be in a country like I am, it's only 10% sales tax. We'll keep it as 20 for now, and of course we then need to name our column. We're going to call it invoice tax amount. So looking at these values here, if we then want to bring in the tax amount, simply select that, execute it, and as you can see there's 20% of our invoice amount. As we go down, a differing value here, we can see that our tax amount differs as well. So what's happening is that the function is being called. It's passing in the invoice amount there, the extended price. It's multiplying it by 20% and outputting this value here. That's all it's pretty much doing. Now, the thing to note with functions is that they can be quite resource intensive because it's running this function for every single row within our select statement. So 71,898 times, that's how many rows we have, and it's running that function off for every single row. So we're not talking about batch processing, it's row by row where it's having to call that function. Fortunately, with scalar functions, as you can see, it's very small. It's got a very, very simple mathematical calculation there. So we know that the function is pretty efficient. But you can imagine if you had millions and millions of rows, it could take several seconds for you to return your results. So that's the function used in a table. You just simply add it in as another column, but then specify the schema and the function name, brackets, open brackets, pass in however many parameters you need to, separated by a comma, and then close the brackets there. So say I lived in a different country that had 10% sales tax, simply change that value to 10. As you can see, the tax amount is a lot smaller there. So that's the great thing about functions, is that you can pass in different parameters, multiply those together or do what you want with those parameters, and as a scalar function, one value gets churned out. Now you can also test your function out by simply selecting the function, passing in various values to get the 20%. Let's have a go with that, simply with your select, and that tells you that tax value based on the 20% amount for this value that we're just sending in is $879, whichever unit of currency you use. So you can check that your function works well there. And that, very simply, is the scalar valued function. Let's have a look at another example for you. In this scenario, the order line table has separate quantity and unit price columns, and we often, as you've seen before, need the total value of each line in our code going forward. As you've seen, we've done a lot of quantity times unit price, and then we have to sum it up, etc., etc. So what we need to do then is create a function to do this work for us, this little simple mathematical equation. So to create one, we need to go about following the same sort of methodology up here, and then we need to test it out in a simple select statement like we've got here. So if you want to give that a go, just follow the steps above here. Let's create this function, and then we'll test it out with a little select statement there. Pause this video, give it a go. When you're ready, we'll go through the answer from my side. Alrighty then, first things first is to create the function itself. Write that out and we're ready to go. We need our schema, and we're going to call this, what should we call this? We're going to call it total line amount. How about that? So it doesn't really matter what you call it. I've called it something quite meaningful so that we can refer back to it later if needs be. Let's look at our code up here. We need to then pass some parameters in. Let's go ahead and do that. So we begin with our little @ symbol there. Now there's two values we need to pass in, quantity and unit price. So what we're going to do and it doesn't matter what you name these. We're going to have quantity, and we know that this is pretty much an integer value. It's working on whole numbers. Now, in theory, it doesn't need to be exactly the same data type as the source table it's coming from, because simply we are passing in values wherever they come from. So what we want to do is pass in an integer there as a quantity, and then the unit price itself, we're just going to call this price, and we're going to float again. That's an easy way to do a decimal. If you're unsure of the amount of digits after the decimal point itself, you can just simply use float as opposed to using decimal. Much easier to use. So we're going to use those two values. Now again, it doesn't matter what you call them. You could call this value 1, value 2, as long as you make sure you get the right data types in there. So we're going to be passing in those two values. Next, we need to specify what it's going to return. Now if it did return an integer, for example, you may miss any decimal points when you multiply by price, which is fine if all you want to do is get the whole dollar amounts. But we want to pass out any decimal points into our code, so I'm going to keep it as a float. And that tells SQL Server that this is going to be a scalar function. And then we begin our actual code, return, and all we're going to do is simply put quantity times price. End it and go. And that is simply that for our function itself. Very, very simple. As you can see, we're sending in an integer, we're sending in a float value, it's going to multiply the two together and return the value at the end as another float. So in theory, although this function is being created to do the job of multiplying the quantity and unit price from the order line table, as you can see, you can simply pass any int and any float in there and it will just multiply the two together. So this actual function can be used in other scenarios, not specifically when you're calculating the total line amount from order line, but as function is being created to do just that, we'll leave it at that name there. Let's execute that. It executed successfully, and let's give it a go. Grab our function there, and if we had a value of 10 quantity at $5.50 each, let's select that, highlight that, execute. As you can see, we end up with 55. Pretty straightforward. If we change that value there and say we had 15 instead, it'll just keep outputting a float decimal value pretty much of this mathematical formula there. Very simple, but very straightforward and easy to do. Let's put a go there, and it'll get rid of any red from below. So that is a scalar function for you. Keeping the mathematical formulas very simple, as you can see here, makes the scalar function extremely efficient. As you add complexity within the function itself, if you're going to be using it when you're calling millions of rows in your results set, things can slow down a little bit. So that is scalar valued functions for you. Everything is designed to return a single value of a specific data type that you specify in that returns there. Now on to some simple table valued functions. So in this case we're also passing in a parameter. In this one it is a year, which we're calling an int, and we're going to pass that into the function and we're going to return an actual table. As you can see here, we've specified returns a table as opposed to a data type like a float, integer, varchar, etc. We're actually specifying let's return a table. So straight away that tells SQL Server it's going to go into our table valued functions there. We have as well, but unlike the scalar valued function, we don't need to use the begin and the end. So if I uncomment that, as you can see, it gets a little bit confused. So for your simple table valued function, all we're saying is as and then our return. And if we're returning based on a simple select statement, we open our bracket, we write our select statement in there, and then we close our bracket there and then hit a go at the end. And of course you can see we are simply putting in our year here as our parameter that we're being passed in here. So all this is doing is selecting this table of values based on a year that we're going to be passing in. So let's have a go at that. Let's execute that and give it a try. So we're just going to pass in 2013 and see what happens. And there you go, it returns a table. So it's kind of like just your select statement. However, you can always change what you pass in for your year. So if I wanted to see, you can see it's all 2013. If I wanted to see the data for 2014, I can simply put in that year and it reuses the same function, so I don't have to keep rewriting my select statement. Put that in, it'll pass 2014 in, and when it's ready to return some results, you'll see that the invoice date is all 2014. What happens if there's no data? So we don't have any data for 2012. It'll of course return no values. So we know our function is working quite well there. You can also call a function within another function. So here, if we wanted to bring in our sales tax amount, the same function that we created right at the start, pushing in the extended price and the tax amount to give us our invoice tax amount, we can call this function within this function here. Now of course, if we want to alter the function to bring in that column, we simply do the good old alter function, run off our code, and there we have it. Control-Shift-R, make sure that SQL Server Object Explorer is updated, and there we go. So if we pump in 2013 again, we can see that our invoice tax amount is now showing 20% of that value equals that value there. Fantastic stuff. So that's all good. We can call functions within other functions as well. Obviously this adds more and more complexity as we go, but a simple table valued function that just returns a table based on a parameter that we're passing in should be pretty simple and straightforward and won't chew up too many resources when you execute your query. Very simple, straightforward. Let's have a go at another little example I've got for you. So the scenario is that the purchasing manager needs a quick and easy way to see some purchase order details per supplier per year. So there's a good indication of some parameters that we might need to use. You need to extract data from the following columns. So we need to get the supplier name, we need to get the purchase order ID and date, then we need the supplier reference, we also need to bring in the total ordered outers and then the total received outers. So it looks like we're going to have to generate a select statement first and then create our function around that for finalized orders only. So we might need some sort of where clause to make sure we only return finalized orders. As data needs to be by supplier and year, we need to build a function where you can pass in parameters for the supplier ID and the order year. Alrighty then, keen to give that one a try? If so, then pause the video, and when you're ready, we'll look at the answer from my perspective. Alrighty, so first things first that I'm going to get out the way is I'm going to put together this little select statement here. And we know that the supplier name comes from our supplier table here. Suppliers, fantastic. Supplier name, so we've got that one in. Purchase order ID. We know that for every purchase order there is a supplier. We can't have one without, so we can use our inner join there. And we've got our purchasing orders here. There's our supplier ID. Supplier ID, fantastic. We join it to that. That'll give us our PO ID and date, and maybe even our supplier reference. Let's give that a go. Let's bring those in. Purchase order ID. And we've got the order date in there. Brilliant stuff. Supplier reference. Is that in there? Supplier reference. There we go. Total ordered outers, total received outers. We have to do some sort of sum there with the order lines, the purchase order lines. So let's put that in a CTE. How about that? And of course with the CTE you can write the select statement outside and then just bring it in as a CTE, up to you. But we'll need to join our purchase order lines on something and probably join it to our purchase orders table, and that'll probably be on the purchase order ID. So let's go for that. Let's select that one first. Let's just drag the table in from our purchase order lines. Purchase order ID. So there's our link for every purchase order ID. And of course we need to get our ordered outers and received outers. outers as well. Received outers, let's spell it all correctly. Third try, yes, we've got it. Fantastic. And we need to sum those up. That's our total received outers. So here we've got our subselect. Let's then bring it in. We can inner join. And we've called it totals st on our purchase order ID equals the purchase order ID in our purchase orders table. Fantastic. So let's bring in those total values. We've got our ordered outers and we've got our total received outers. So let's run off that code very quickly. Invalid in the select list. What have we forgotten to do? We've forgotten our little group by here. Easily done, as you can see. Run that off, and here's our data. Fantastic stuff. So we only need to do it for finalized orders only. So where is that coming from? I presume it's in this table here. Is order line finalized? Do we have it within this table? Is order finalized? So let's go for that. I'm going to put it in the inner join. You can of course put it in your where clause. Makes no difference on the inner join. Is order finalized? 1. So that makes sure we only return values based on the filter there. Fantastic. Right, now as the data needs to be by supplier and year, build a function where you can pass in parameters for the supplier ID and order year. So we're happy with our select statement. That's all good. So let's then create our function around that. We're going to put it in. Let's go for the purchasing schema instead for a change. How about that? Seem to be putting everything in sales, but let's use another schema for this one. Function POs. We're just going to call it POs. Now let's get in our parameters, and we need to pass in the supplier ID, which I think is an integer. Supplier ID. Let's have a look at that table. Control 3. Supplier ID looks to be an integer to me. ID int, and we then need to pass in the order ID, order year, which is also an integer. Fantastic. So we set up our parameters there. What do we want it to return? What do we want our function to return? And of course it is a table. As, let's have a look what's going on here. Return open our brackets, close our brackets, and go. So that's pretty much it. But as you can see, we're not actually consuming these two parameters within our select statement itself. So we need to bring those in. And as you can see here, I've simply done it within the where clause. You can of course put them as well in your joins, just like I've done here. So let's go about doing that. So first of all is the ID, and that's going to be based on the supplier table. We're going to do it based on that. You can also do it based on the purchase orders, but as supplier is pretty much generated from this table, we're going to use that. Supplier ID equals, there you go, so that's our ID parameter brought in to filter our suppliers table, and then of course we've got the year of the purchasing order. We're going to add it into the column, and again you might have added it into the where clause, that's perfectly fine. That's the order date equals the year there, and of course we need to put our year function on it. And that's pretty much it for this example. Pass in purchasing order ID and the year. We need to calculate some totals with our little CTE there. Bring it all in a select statement, which we built up first. Remember the syntax for your function. Create a table as return, open the little brackets, write your select statement, close it off there, and then you put your parameters to filter your result set. There you have it. Let's see if this works. We'll create that function. Seems to have worked there. Let's grab that quickly. In fact, we'll just do star from PNFOs, and now we have to pass in our parameters. So we're going to pass in an ID of 1, and I don't know if there is actually a supplier of 1, but we're going to go for it anyway. We'll see what they did in 2013, shall we? If they did anything. Nothing at all. So we might spend quite a bit of time trying to find a relevant purchase supplier ID. Let's have a look at our purchase orders table. In 2013, supplier number 4, he placed 2 orders there. So let's pick supplier ID number 4, and in 2013 we should see a whole lot of purchase orders being placed. And there you have it. Pretty simple and straightforward. We've got our results there. As you can see, the supplier is Fabricam throughout the whole result set, and is ordered, the year of the order is 2013 there. So we're quite happy that our function works. So remember, if you are ever building a function, tabular function, simply write your select statement out first, make sure it's working correctly with whatever CTEs or subselects you use in it, and then build your function around that, adding in your parameters for your filtering in there. And that is the simple table valued functions. Also, we've learned that you can call a function within a function, and you can keep doing this, functions within functions, as you choose. So that wraps up this lesson, where we've learned all about scalar and the table valued functions, how to create and how to alter those functions. Of course, you can always drop them or simply right click and delete them from the Object Explorer if they're no longer needed. So join me in the next video where we look at stored procedures, which is just another way of using our select statement. Until then, everyone, I hope you all have a fantastic day.